Okay, for my forces and circular motion reassessment, I came up with this problem. Can you hear me? A fan is spinning by a motor so that it rotates with an angular velocity of 200 rad per second. The motor is turned off. There is friction in the bearing so that as it spins, it has an angular acceleration of negative 1.50 rads per second squared. In this case, the fan blades are not slanted to push or pull air. How many times will it rotate before stopping? So I wrote down what I knew. The initial angular velocity of 200 rads per second. The angular acceleration of negative 1.50 rads per second squared. This is going to be my final angular velocity, and we're trying to find theta. So this is my formula that I'm using. It's the final angular velocity squared equals the initial angular velocity squared plus 2, I think that's lambda, which is angular acceleration, change in, what are we trying to find? Oh, rotations. So the amount of rotations. So what I did is I plugged in what I knew. So my final would be 0 because it would be stopped. And my initial is 200 rads per second squared. I have to add that squared in. Plus 2 times negative 1.50, which is my angular acceleration, change in theta. So what I did was I squared this 200 and it gave me 40,000, and then I distributed this 2 to this negative 1.50 and that gave me negative 3. So I took 40,000 away from both sides, and that left me with negative 40,000 equals negative 3 change in theta. Then I divided by negative 3 and that on both sides, and that canceled out this side to leave me with theta, and that gave me 13,333.33 rad equals theta. And then so what I did here was I referred to the unit circle, so it's 13,333.33 divided by 2 pi because it's a full rotation, and that gave me 20,943.95 rotations. And to find the change in time, I took the angular acceleration formula. It equals change in angular velocity divided by change in time. And that gave me, so I plugged in negative 1.50 for my angular acceleration, and then I took my final velocity, my final angular velocity, which was 0, minus my initial, which was 200, divided by change in time, which I'm looking for this change in time. So then I once I worked out this equation by taking negative 200 divided by negative 1.50, the time I got was 133.33 seconds. So that is my forces and circular motion reassessment.